Okay, so now we are going to discuss lines. Again, one of those other topics with triangles that is a favorite. These people really like to deal with questions about lines. So let's start with the basic concept. The equation. What is the equation of a line? So remember that the equation of a line is given by y to be equal to mx plus b. From here, I need to be super clear what is the m. So remember that x and y in the equation will be, again, y and x. But this m in reality will be a number. And this number, this m, is what we call the slope. Okay? And I want you to understand the slope, compared as the inclination, okay, of the line. The inclination respect the x-axis, okay, in the xy plane. So the slope is the inclination. Now, that is a number, as we said. We're gonna get an example in a minute. So the thing is that as this slope is a number, we have, let's say, three possibilities for the number. We know that the number represented slope can be a positive number. We know that that number can be negative, or we know that that number eventually could be zero. So what do we know from there? If the number representing the slope is a positive number, what we know automatically is that the line will go in this direction, kind of going upwards. Now, if the number representing the slope is negative, we know that the line should be going down, okay? Like in this direction, going downwards. And if the number or the slope is zero, that means that you see a 0x, or eventually you have an equation where you don't have an x, meaning that the slope is zero. The slope of zero represents a horizontal line. Okay, the line is 100% completely horizontal. Okay, that about the slope. Now, what does this other number, this b will be another number, so what does this number represent? This represents the y-intercept, okay? And what there is the y-intercept, what we mean is the point, at which the line crosses the y-axis, okay? The y-intercept is that point at which the line crosses the y-axis. That is what the number b will represent, okay? So let's put that into an example, okay? So here's an example. We might have this equation. We might have, I don't know, y to be equal to 2x plus 3. So if we were to draw this line in the xy plane, so this is the xy plane, this is x and this is y, always analyze the y-intercept. So check out here the y-intercept, you know that is this number. If you compare this equation to this form, the slope is that number, whatever number it might be, that goes with the x, and the b, that is the y-intercept, is the number that goes along. So in this case, the y-intercept is positive 3. So I know that the line will go here, let's say that is 3. And we analyze the slope is 2. Check out, 2 is positive 2. So from this information, we know that the line must be going up. So if I were to draw this line up, I could say that the line should look something like this, approximately, right? It goes up and it goes through y equals to 3. Okay? Let's get another one. If I give you this equation for y to be equal to, I don't know, 5x minus 2. So we pay attention to the y-intercept. In this case, check out, that is the one number that is alone, negative 2. So that line will go through here. This is negative 2, right? And check out the slope. The slope is, again, 5. It is positive. That means that the line is going to go up. But remember, the definition of the slope is the inclination. So if I compare 2 and 5, 5 is greater. The greater the number is, the more inclined the line should be. So if I draw this, and it's kind of making some sense out of it, line in green should be going upwards, but should look more inclined than the one in yellow because the slope is greater, right? The slope is greater, so I'm going to try to draw it maybe like this. That could be the representation of that line in green, okay? Hope that this is clear enough. A couple of more aspects regarding the equation of the line. There might be several questions where they don't give you the equation of the line just like this, like y equals mx plus b. They might come and give you a line, an equation that looks maybe like, I don't know, let's say that they give you 2x plus 4y equal to, I don't know, 36, okay? And if you have an equation with x and y, we can rewrite the equation to represent or to resemble the equation of a line. So, and that is always going to be my recommendation. If you see an equation like this, the recommendation is solve for y. Why? Because when you solve for y, you will be able to see the equation on this form, the basic form of a line, and from there we can deduce what will be the slope and what will be the y-intercept. So let's do that step by step in this case. I'm going to solve for y here. If I solve for y here, I will have 4y equals to 36 minus 2x, right? I continue solving, so I will say that y is equal, I'm going to rearrange these ones just for the purpose of make it as close as possible to the general equation of the line. So it's negative 2x plus 36, everything over 4, right? And I solve for y, but here, very important, the next step is going to be quite important. Whenever you see this, we talk about arithmetics, here you can split the denominator. So I can again rewrite the equation in this form. Minus 2 over 4x plus 36 over 4. See what I did? I took the 4, I split it, 1 4 on this side, 1 4 on this side, and just by solving this guy, I have that y, this will be negative 1/2 x plus this will be 9, right? And check out, when we get it here, if you see this equation, it resembles the general form of a line. So remember that the slope is whatever goes with the x. So from here we know that this guy is the slope, negative 1/2, and we know that 9 is the y-intercept, okay? So that's why this is kind of a common practice in the test. They might give you the equation of the line in this form. You just need to solve for y. Pay attention to this step right here. I'm gonna make it here. Pay attention here. Now you can split the denominator. So you can have it very clear and see again, whatever goes with the x, whatever number you end up having with the x, that will be the value of the slope, and whatever number is alone, that will represent the y-intercept. All right? One more thing about this equation, and it is the m. Okay, we have a little equation that we tend to use, and every now and then it's going to be common. Whenever you're given 2 points on a line, okay, you have point x and y. Let's call this point 1, and they say that there's another point x and y, and this is point 2. Whenever you are given 2 points on a line, with those 2 points you can find this slope applying this little formula. That is the difference of the y's, so y2 minus y1, divided by the difference of the x's, so x2 minus x1, okay? This is how you will be able to find the slope in this case. Some of you might have studied this. The slope will be what you call the rise over run. The rise representing the variation of one point as it moves on the y-axis, and the run like the same variation but on the x-axis. Okay, so keep those two in mind as well. Very useful, very handy in many different questions regarding the lines. All right, so now let's continue with complementing the topic of lines. We're going to talk about lines, and we're going to see how can we connect lines with a system of equations, okay? This is also a very common question. And here, what we're going to be talking about is that they might give you 2 equations, and that will be a system of equations, but whenever you see those 2 equations, you can think of lines, right? So, for example, let's take the one that we were working with just before, that it was, I think that is for x equal to 36, right? And let's come up with another equation. Let's say that you have another equation that is minus 3x, okay, plus y, this will be equal to 18, let's say, okay? So we have a system of equations. As these equations are dependent on x and y, automatically we can think that these equations could represent lines. And if that is the case, okay, again, I will tell you that it could be a good idea for you to solve them. Let's say rewrite them.
YouTube has this result.
And this will represent two lines. Okay, so you can rewrite, as we just saw before, rewrite these equations and visualize them as lines in the form y equals mx plus b, all right, if necessary. Now, the important thing here is that these are simple equations. We already know how to solve system of equations. So here, if we just solve the system of equations right here, the solution to the system of equations, to this system, graphically speaking, is the point of intersection of the two lines, point of intersection. So if we solve the system of equations right here, okay, if we were to solve it, we will find a point that will be point xy, and this point are those values of x and y that make both equations true. And this, graphically speaking, is the point at which the two lines cross, okay, in the xy plane. So let's try to see this thing visually, okay, visually speaking. Again, let's start by solving the equations, or no solving, like rewriting them. So the first equation, if I rewrite it, again, let's do it step by step, is 4y equals to negative 2x plus 36, y equals to negative 2 over 4x plus 36 over 4. So y is equal to negative 1/2 x plus 9. So I know the slope and I know the y-intercept, right? The second expression, let's rewrite it. If I rewrite, I will have that y is equal to 3x plus 18. And well, that's it. We know the slope and we know the y-intercept, right? So let me rewrite this guy in green so we can draw it in the xy plane and you will see more clearly what I'm talking about the intersection. So if we were to draw these lines in the xy plane, x and y, so the first one, the one in yellow, we know that the y-intercept is 9, so this will be 9, maybe here, and the slope is negative, right? So negative 1/2, so that means that is going down. So the slope doesn't seem to be that big, so if I draw it, I could be saying that is this line, right? And the intersection is 9. Now, if we draw the green line, the interception, y-intercept is 18, so it should be double, so maybe making sense, this could be the value. And the slope is 3, positive 3, that means that the line is going up, right? So if I draw it, and it's going to be much more inclined, so if I draw it, this might be the line, okay? So this point right here is where they intersect. This point right here. This is point xy, that is the solution to the system, okay? That's what we're saying. The solution of a system of equations is a point xy, and graphically speaking, that represents the point at which the two lines intercept, all right? Clear? So if these lines intercept at any given point, that point is the solution. We have to talk about other concepts based upon this information, that the solution of a system of equations is the point at which the two lines intersect. So the first concept is like if the system has no solution, what does that mean? If the system has no solution, that means that the lines never intercept, right? There are two lines that will never intercept. That's what it means. If the system of equations has no solution, the lines never intercept. They can also be that the system has infinite solutions, okay? What does it mean if the line has infinite solutions? basically the two lines, or the two equations, basically better, the two equations that we might dealing with, the two equations represent the exact same line. So that means that if I draw one equation, one line, and then I draw the other one, they will like overlaps, like let's say that I have this line, and then when I draw the second line is like basically on top. So like the line is intercepted at infinite points. That means that the system of equations has infinite solutions. Okay, keep those two concepts in mind. Besides what we first studied, so if the line has one solution, I mean the system of equation has one solution, that solution is the point of intersection of the two lines. If this system has no solution, that means that you have two lines that will never intersect. And if the lines has infinite solutions, that means that one line goes on top of the other one and they will be intersecting in infinite points. Okay? Now, let's talk about parallel lines. So, which are parallel lines? Remember what we were talking about? Lines that never intersect. So, parallel lines, these are lines that never intercept, right? Never intercept. If the lines never intercept, remember that parallel lines, again, will represent, these parallel lines represent a system of equations. Let's write the whole thing, system of equations with no solution, okay? That's what it represents. A system of equations with no solution, if we have two parallel lines. Now, being very punctual, if we talk about a system of equations, that means parallel lines. How do we know that two lines are parallel? Because they have, like the two lines, in order to be parallel, they have the exact same slope, okay? The slope is exactly the same. This is the big concept, all right? So, if you have these equations, 2y minus 36, whatever. You have another line that this might be 2x plus 9. So check it out. We analyze the slope here is 2, the slope here is 2. This is the same slope, so these two lines are parallel. These two lines are parallel lines. It does not matter, it doesn't matter the point of intersection, the value of b, but the slope is the same. We have two parallel lines. That's it. That represents a system of equations with no solutions. The lines will never intersect. So again, applying this concept, regardless of the equation that you have, always solve for y, so you know exactly what you're talking about. And if the slopes are the same, you have a system of parallel lines, meaning that the system itself has no solution. The lines will never intersect. And to wrap it up on this topic of lines, we also have the concept of perpendicular lines. So which are the perpendicular lines? So these lines intercept, okay? So there are two lines that intercept, right? But at the moment of interception, they form, forming a 90-degree angle. That's the meaning of perpendicular lines. So basically we draw them, a line here, a line here. So they intercept at this point, but when they intercept, they form a 90-degree angle. Those are two perpendicular lines. What is the important aspect here? Talking about the slopes. There are questions that will try to evaluate this concept. If I have two perpendicular lines, what we know about the slopes is that the slope are opposite in sign and inverse in value. So these are the two big aspects. The slopes are opposite in sign and inverse in value. Okay? So let's draw here an example. Let's say that I have these two lines, okay? And they are perpendicular here. So let's say that the slope here, the slope of this line, the slope is, I don't know, 2. So the slope of the perpendicular line again, let's start. They are opposite in sign. So this is positive 2, so I know that the slope of the perpendicular line is negative. And inverse in value. So what is the inverse of 2? The inverse of 2, if you remember, is equal to 1/2. Okay, is that clear? Let's give another example with equations, right? Let's say that is an example with equations. If I give you, and you have one line, and the line is equal to, I don't know, 4/3, let's say that is negative 4/3 x plus 9. So if I want to deduce what will be the slope of a line that is perpendicular, so keep in mind that the slope of this line is 4/3. So the slope here is negative 4/3, right? And if the slope here is 4/3, right? If the slope here is 4/3, that means that the slope of the perpendicular line will be equal opposite in sign. So this is negative, so this guy will be positive, and inverse value. So remember that inverse is like kind of if you flipped the fraction. So it will be equal to positive 3/4. This will be the slope of the perpendicular line. Okay? A concept that, again, every now and then will be useful. So keep it in mind. Again, hope that this quick review helps you. As always, may you have any sort of questions, contact me and I'll try to get back to you as soon as possible.